This tutorial is about lighting and rendering glass. You may have noticed that taking photos of highly reflective objects is notoriously difficult, and taking photos of glass objects is even harder. The reason is that amorphous surfaces reflect the environment perfectly, just like a mirror, and if the objects have curvature, they will gather reflections from all over the place. And when the surfaces are also transparent, they refract the incident light in pretty much unpredictable directions. So what makes glass different from other materials? The reason why we can see things is because of the light objects reflect back to us in a diffuse or specular fashion, and often as a mixture of both. Let's consider both extreme cases. A fully opaque and matte object shows only diffuse reflections, because the incident light is scattered randomly in all directions. In contrast, a transparent and glossy object not only shows perfect specular reflections, it also refracts and transmits over 95% of the incident light. Light you aim at glass objects just passes right through. Let's consider some typical glass rendering issues. Front and ambient lighting on an infinity curve don't help to model a glass object's form because glass causes no diffuse reflections. The lack of defined reflections and low contrast can make glass look a bit dull, or even like plastic. On the other hand, a cluttered background and environment make reflections distracting and difficult to control. In other words, classic multi-point lighting setups or backplates with HDR images don't work well with glass objects. However, you can achieve more photographic or artistic results when you forget about lighting glass objects directly as if they were opaque. For predictable results, you can use classic glass photography techniques, meaning you only work with the reflections and refractions of light. So let's look at some basic examples. Bright field lighting, dark field lighting, indirect lighting, multicolor rim lighting, and lighting liquid on a dark background. Once you understood how these setups work, you can easily modify and combine them. Let's create the 5 classic setups shown before. Open Maxwell Studio and load a standard beginner layout using the Windows menu. Create a new camera and rename it, then set the resolution to Instagram format. Using a long lens eliminates perspective distortion, and a low f-stop provides a nice depth of field. Instead of pushing the lights to unrealistically high values, simply adjust the ISO and shutter speed to change the overall brightness, just like you would using a physical camera. Set the camera location and focus target numerically to keep things perfectly centered. Import the glass OBJs and rename them, then orient them either numerically or using the W and I keys like in Maya. Open a glass material and drag it onto the 2 wine glasses in the viewport. Then hide the liquid OBJs until later. Clone the glasses and reflect them vertically. This way you get perfect reflections of any background, a classic studio photography trick. Drag a 1x1 polygon plane from the library to the viewport and turn on the normals display to see which side faces forward. Now reposition the plane behind the glasses. Create a new emitter material and load an HDR softbox image, then rotate it 90 degrees and keep the intensity at 1. Drag the emitter material onto the plane in the viewport. Clone the softbox, rescale and reposition it so it overlaps the softbox on the left. This plane will become one of the 2 blocking cards in the first setup. Load a black Photo Studio paper material and drag it onto the blocking card in the viewport, then clone it and shift it to the right. In case you are wondering, the Photo Studio paper material has no texture mapped, which is why you see its bare UV set in the texture decal mode. Change the viewport to the new camera and activate the interactive renderer to get an idea about the lighting and depth of field of the scene. If you're happy with the result, start a full-size rendering to SL19 or 20 to get a noise-free image. Next we create the opposite look, picking out the glasses in white on a black background. Clone the previous camera and change its shutter speed. Clone the softbox and hide the original, then position the plane a bit closer to the camera. Clone the left bounce card and reposition it, then hide the previous two. Clone the cloned softbox, then rotate, reposition and rescale it also. Clone the softbox emitter material and load an HDR softbox strip image, then drag the material on in the viewport. Change the emitter intensity to 1.5. Change the viewport to the new camera and activate the interactive renderer to get an idea about the lighting and depth of field of the scene. If you are happy with the result, start a full-size rendering to SO19 or 20 to get a noise-free image. Now we use a colored spotlight for indirect lighting. Clone the camera and change the shutter speed as before. Drag a 1x1 polygon plane from the library to the viewport and position it slightly forward. Then load a black shiny plastic material and drag it onto the plane. Hide the reflected wine glasses. Clone the table slab plane to make a bounce card, then rotate and reposition it to create a gap between the bounce card and table slab. Don't forget to hide the softbox and bounce cards from the previous setup. Load a white Photo Studio paper material and drag it onto the bounce card, then add a bump map texture for a bit of detail. Drag a spotlight from the library to the viewport. Rotate and position it so it illuminates the bounce card from below. Change the spotlight's cone angle, fall off, color temperature and lumen output. Change the viewport to the new camera and activate the interactive renderer to get an idea about the lighting and depth of field of the scene. If you're happy with the result, start a full-size rendering to SL19 or 20 to get a noise-free image. This setup uses nothing else but a few colored lights. Clone the camera, reposition it slightly and change the f-stop and shutter speed. Unhide the reflected glasses again and hide the spotlight, table slab and bounce card from the previous setup. Clone the left bounce card from the first setup and unhide it, then rescale and reposition it. Create a new emitter material and load a green HDR cell dish image, change its intensity to 2 and drag the emitter onto the cloned bounce card in the viewport. Clone the plane and shift it to the right, then clone the previous emitter and create a red version. Clone the plane and rotate and reposition it, then clone the previous emitter and create a blue version. Clone the plane one more time and rescale, reposition and rotate it, then clone the previous emitter again, turn it into a white Fresnel spotlight and drag it on. Change the viewport to the new camera and activate the interactive renderer to get an idea about the lighting and depth of field of the scene. If you're happy with the result, start a full-size rendering to SL19 or 20 to get a noise-free image. With a multi-light function, you can easily adjust the brightness of each light or create a different photographic mood without having to re-render, which is a huge time saver. In the final example, we light glass with a liquid on a dark background, again with only a single light source. Clone the camera as before and change the f-stop and shutter speed for a larger depth of field. Hide the previous scene's objects and reflected glasses, then unhide the liquids. Open two different red wine materials and assign one of each to a liquid. In order for liquids in glass to render correctly, you must set the liquid material's nested priority to 1. Clone the softbox from the second setup and unhide it, then rotate and reposition it. Clone an emitter material and load an HDR softbox gradient image. Adjust the intensity and drag that into the softbox in the viewport. Unhide the table slab, reposition and rescale it. Then clone it to create a wall slab and rotate and reposition that also. Load a slate material and drag it onto the table and wall slabs in the viewport. Clone the bounce card from the third setup and unhide it, then reposition, rotate and rescale it. Import the two reflector foils into your scene and rotate them. Angle and reposition the reflectors behind each glass so they are hidden from view but still catch light from the softbox. This way, the liquids that would otherwise appear almost black because of the dark background behind them will look illuminated. You could assign a white photo paper material, but to make it more realistic, we'll use a wrinkled aluminium foil material, which also helps to introduce some subtle irregularities in the reflected lighting. Change the viewport to the new camera and activate the interactive renderer to get an idea about the lighting and depth of field of the scene. If you are happy with the result, start a full-size rendering to SL19 or 20 to get a noise-free image. And now it's your turn. Thank you for watching and listening.